Hello. Today we'll be learning about wave superposition and interference. I'm Anchita.
And I'm Rohit.
Before we dive into the concept of wave superposition specifically, we must understand what a wave is. A wave is a propagating dynamic disturbance of one or more quantities. This disturbance travels through a medium from one location to another location. A medium is a substance or material that carries the waves. For example, when we think of waves, we usually think of ocean waves. The medium that carries these ocean waves is water. Now that we understand waves, let's talk about the wave concept superposition. Wave superposition is when waves pass through each other without being disturbed. This principle of wave superposition can be applied to waves whenever we have two or more waves traveling through the same medium at the exact same time. In the GIF below, we see a superposition of two waves. These waves share the same amplitude, frequency, and wavelength. They are also traveling in the same direction. Notice how the resultant wave has an amplitude twice the size of the original wave. This resultant wave's perfect increase in size can be attributed to the idea that the displacement of the resultant wave is the sum of the displacement of the constituent waves. In algebraic terms, let wave 1 be equal to y of 1 is equal to x of 1t, and wave 2 be equal to y of 2 is equal to x of 2t. Add these two up, and we get the sum of y of xt. So far, we have seen examples where displacement is doubled. This leads me to the concepts of constructive and destructive interference. If the two waves are completely in phase with one another, then the resultant will be double the amplitude. This is called constructive interference. Alternatively, when two waves are completely out of phase with one another, they will cancel each other out completely, leaving nothing. This is called destructive interference. Now, Rohit will explain wave interference in practice. Rohit, are you there?
Oh, sorry. I was listening on my noise-canceling headphones that were perfectly destructive of what you were just saying. Okay, so in this example, we have two speakers playing music with the same amplitude but out of phase. Speaker 1 is with the red, and speaker 2 is in the green. These two waves can be modeled by the equations on the right. The resultant wave is the blue wave in the bottom that is modeled by that equation. These waves are out of phase and have the same frequency, which will result in an amplitude of the blue, which is bigger than the red and green waves, therefore being louder. So in the next slide, here constructive interference occurs when the phases line up with one another. When we move the green wave to shift it to the left a little bit to line up perfectly with the red wave, we get a resultant wave that is twice the amplitude. That's because the phases line up with one another. This phenomena is called constructive interference of waves. Next slide, please. When we shift the green wave to when we shift the green wave's troughs to line up with the peak of the red troughs, they cancel out and result in an amplitude of 0 in the blue wave. This is what happens when noise-canceling headphones will listen to the outside audio and provide waves that cancel out the outside surrounding sound. This allows the listener in the headphones to kind of tune out the outside environment. Next slide, we'll be talking about diffraction. Diffraction is the bending of waves around small obstacles and the spreading out of waves beyond small openings. This can be described as like if you're in a party and you have your door open, you'll be able to listen to the sounds of the party because the sound waves travel through your door and spread out into the room. Long wavelengths sounds diffract efficiently than shorter wavelength sounds. Next slide shows an example of this. If a marching band is approaching you on a crossing street, which instrument will you hear first? The piccolo, which is a higher pitch and shorter wavelength, or the drums, which is low pitch and long wavelength? You are the figure at the very bottom behind the building. I had to think about this for a second, and I recalled why armies use drums in their front lines in movies. I was able to answer this question by thinking to that example. Drums are lower pitch and have a longer wavelength, so they're able to travel out farther. So in that's why in these movie scenes you'll see people hearing the low beat of a drum, and that kind of warns them, hey, an army is approaching. All right, next slide, please. So what we learned today has an immediate application. This assignment provided me with the knowledge of where to set up my subwoofers for my home stereo system. The overall effectiveness of a subwoofer is for the low bass tones to kind of travel out to wherever you're sitting. It's a low frequency, so the placement of the speaker is very much important. The best way to set up your subwoofer is to face it in the open air and have the enclosure face towards the wall. In this case, the low frequency bass will likely sound muffed if the speaker is facing towards the wall, because the waves will travel up the wall rather out into the air and towards your ears. So next slide. Wave superposition is used in many applications. One application we learned today is in noise canceling headphones. For noise cancellation to occur, the waves need to interfere with the inverse waves. So the speaker will be actively listening to the outside environment and providing this anti-noise that cancels out the outside environment, so you can only listen to your speakers. This actually proved very dangerous because like some people would be crossing streets with these busy streets with these noise canceling headphones and not be able to hear the outside environment. So to combat this, certain newer speakers, headphones, have a ambient noise feature, which will allow certain outside noises into the speakers, so you're not totally canceling out the outside. This is done by using constructive interference than canceling out with destructive interference. So thank you all.